Hi, and welcome to part 3 of this series of videos about analyzing subnets. Back in the first video, we talked about how you needed to have unique, non-overlapping subnets in your design, and that's something you can check on the exam for problems to answer questions. The second video, we talked about how hosts needed to be in the same subnet as their gateway routers and how you need to verify that. In this video, we'll turn that second video around into an analysis of neighboring routers. Routers that neighbor each other on the same data link need to have IP addresses in the exact same subnet. For instance, in this figure, we have 3 routers connected to the same switch, and they're all in VLAN 2, for instance. So they're all neighbors. That is, they can send LAN frames to each other, and they're all attached to the same subnet, or should be. So what happens if they're not connected to the same subnet? Well, as it turns out, a couple of the most important routing protocols, namely EIGRP and OSPF, don't even work. You can't form a neighborship from a routing protocol perspective if the router that you're trying to neighbor with thinks it's a different subnet. The protocols simply don't work. The other problem is routing holes. For instance, let's consider R1 on this common LAN to have IP address 10.1.1.1, and let's say its mask is /24 to keep the math easy. Router 3 over there has 10.1.3.3 for its interface. Now, a little quick analysis of R1's IP address tells us that that IP address and mask implies a subnet that is essentially all addresses that start with 10.1.1 and have anything in their last octet. Clearly, R3's IP address is not in that subnet. So let's just say that router R1 does learn some routes and it has a next hop address of 10.1.3.3. Well, R1 doesn't even know how to forward packets to that address. It doesn't have a connected route that matches that address. R1's connected route matches only addresses that start with 10.1.1. So you have some black holes with your routing. All in all, you want to make sure your neighboring routers have IP addresses in the exact same subnets. Now let's take a look at a typical WAN topology with 4 routers, and there are 3 pairs that have a point-to-point serial link between them. In that case, on the WAN, there are 3 subnets. In this case, one between router 1 and router 2, another between router 1 and router 3, and then, of course, between router 1 and router 4. However, the IP addresses on either end of the link, say between R1 and R2, there's nothing stopping us from configuring these addresses so that the 2 routers disagree about what the subnet is in between them. So you want to make sure and check the IP address and mask on each side, make sure you calculate the subnet ID and range of addresses to confirm that they are indeed the exact same subnet. Likewise, do that on all the serial links. Next, let's take a look at frame relay in a case where you use point-to-point subinterfaces. Now, point-to-point subinterfaces mimic the logic of point-to-point physical interfaces. So say in this case, R1 had a PVC connected to R2, a different one to R3, and a different one to R4. If we configure point-to-point subinterfaces on all the routers in all cases, it mimics the point-to-point serial links. So you'd have 3 subnets, and in each subnet there'll be 2 IP addresses. These can be configured incorrectly so that the subnets disagree between the 2 routers. So what do we need to do? Do the math and make sure they're in the same subnet. Finally, let's talk about a case with a full mesh and frame relay where we've got a PVC between each pair of routers. Now, in this design, you can use multi-point subinterfaces or even physical interfaces for your configuration, and configure your IP addresses on those types of interfaces. In that case, all 4 routers would be attached to one subnet. In that case then, when you're checking your IP addresses, we need to make sure that all 4 routers agree to the subnet. All 4 routers, if using their IP address and mask, would calculate the same subnet ID and the same range of addresses in each case. Again, what's the problem? You may have routing black holes, or you may not, and your routing protocols may not even become neighbors and exchange routes. In summary, anytime routers are neighbors, anytime they're on the same VLAN or on either end of a point-to-point link, either end of a point-to-point setup with frame relay, or all the routers connected to the same multi-point frame relay design, you need to make sure they have the same opinion about the subnet. It is possible to misconfigure them so they aren't in the same subnet. So on the exam, make sure to do the math and check to see if that's the problem.